Here we go. All right, so guys, I left you yesterday with seeing that there's different ways to measure an angle. We have angles of rotation, that we can create angles of any size, positive or negative. You can measure that in degrees. Then we saw you can measure an angle in degrees, minutes, and seconds. And that helps with navigation if you're trying to kind of pinpoint exactly where something is located. And then the third one is in radians. And guys, this is the one we're going to use for the rest of the year. And you kind of have to like open up your hearts to it. And guys, I've been teaching for 17 years now, and my heart still loves degrees. If you tell me 45 degrees, man, I can picture that in a second. You tell me pi over 4 radians, and I'm like, all right, I'm with you. I know what that is. So I get it. Radians are not going to feel warm and fuzzy and cozy to you because they're not what you're used to. But you have to understand that they are a much more useful way for us to measure an angle. And that's the way you're going to measure an angle in calculus all the time. All right, so here we go. What is radians, right? What is this unit of measurement that we use to measure an angle? So basically, radians measure an angle as a real number. So if you think about it, a degree isn't technically a number, it's a degree. So if I was going to label a coordinate plane, an x and a y axis, I can't label it in 1 degree, 2 degree, 3 degree, because they're not numbers, they're degrees. So what a radian is going to do is it's going to let us all label the x and y axis with an angle measurement that's a real number. So it measures it as a real number. All right? The size of an angle in radians depends on the number of radii, which is just plural for radius, depends on the number of radii that fit into the length of the arc formed by that angle. It is a ratio of the length of the arc to the length of the radius. So that's kind of like, sounds like you just spoke another language, lady. I get it, but it's not that bad. This is what a radian is going to do. So guys, picture a circle, right? I put it on the coordinate plane centered at 0, 0. Everybody knows what the radius of a circle is, right? It's the distance from center to side. So right now, the radius of this circle is that long. That's how long the radius of this circle is. That's the length of it, that's the distance. So a radian says this: if you were to take the length of that radius and start to walk it on the outside of this circle, right? If I was to walk the distance of that radius on the outside of the circle, then the angle, or the central angle, the angle formed by the length of that arc, which is the length of your radius, forms an angle inside the size of 1 radian. So for every radius that fits on the outside of that circle, there is an angle formed the size of 1 radian on the inside. So go ahead, walk another distance of that radius on the outside of that circle, and another angle the size of 1 radian is formed. So for every radius that fits on the outside of this circle, there is an angle that is formed the size of 1 radian. So guys, right now, from here to here, that's 2 radians. It's not, it looks like what? I don't know, like 130 degrees, but it's 2 radians. So that's what a radian does. It measures the length of the arc, and then depending on how many radius fit into the length of that arc, that's the measure of the angle in radians. So if you picture any circle, right, and you have a radius, as whatever arc is created, you just keep walking along the outside. Right now, that angle in radians, that angle measurement in radians is the length of the arc, and then how many of these radiuses fit into the length of that arc. So this angle will equal the arc S divided by the radius. How many radiuses fit into the length of that arc? And that's how you measure an angle in radians. It's measuring it almost as a length or a distance. How many of those radiuses fit into the length of that arc? All right? And again, you can just keep going. Walk another distance of that radius. There's another angle the size of 1 radian. Okay? So again, for every radius that fits on the outside, there is an angle the size of 1 radian on the inside of that circle. All right, so I wrote it all over here. 1 radian equals an angle formed by an arc the length of 1 radius. 1 radius on the outside equals the angle the size of 1 radian on the inside of that third circle. So again, the angle is always measured by the length of the arc, S, and then how many radiuses can fit along that arc. So S over R. So the arc divided by the radius. That's how we measure an angle in radians. All right, and then again, if you think of this as over 1 and you cross multiply, then you get the arc length is always equal to theta times radius. Just another formula for us to be able to use. I always just use this one because that's the one I can always remember. I always know the angle is going to equal the length of the arc divided by the radius. How many radiuses fit into that arc? That's how we measure something in radians. All right, so now we have some conversion factors to make. So guys, we know that if we go all the way around the circle, 1 complete revolution or rotation, how many degrees is that? How many degrees all the way around? 360. Well, if 360 degrees live around an entire circle or inside it, how many radians live inside it? I mean, guys, we can already see 3 radians live inside of it. I mean, this is a rough estimate, but we already know 3 radians. How many full-on radians live inside of a circle? Well, what is the distance all the way around the circle called? What do we call that? The circumference. So the circumference is equal to 2 pi r. So if you rotate all the way around, the length of that arc is the circumference. And then to find out the measure of the angle formed all the way around, you have to find out, well, how many radiuses fit all the way around a circle. So if I want to know how many radius fit around the circumference, divided by the radius, how many fit into that? And they cancel your radiuses, and you're left with 2 pi. So 2 pi radians live inside of an entire rotation. So guys, 2 pi, it's 2 times 3.14. That's roughly 6.28 radians. So that means about 6, right? Hold on, I'm just trying to draw the picture. So that means 6, 1, 2, 3, 4, 5, 6 full radiuses, and then about 0.28 radiuses fit around an entire circle. So that's our main conversion factor. 360 degrees all the way around a circle, 2 pi radians all the way around a circle. There's about 6.28 radians in 1 complete rotation. But again, 6.28 is an estimation, so we say it as an exact measurement of 2 pi. So a lot of times when you measure something in radians, it's a fractional version of pi, all right? All right, so obviously you can tell 1 degree is like, what, this big? 1 radian is clearly a big difference between 1 degree and 1 radian. So if you want to know, well, roughly, just for the picture of it, how many degrees live inside of 1 radian? Well, guys, think of it. 1 radian out of 2 pi radians is equal to how many degrees out of 360? Let's try and find out roughly what is 1 radian equal to in degrees. So 1 radian out of 2 pi should be equal to how many degrees out of 360? So cross multiply, and you get 2 pi x equals 360. To solve for x, divide both sides by 2 pi, and x will equal 360 divided by 2 times pi, which again is roughly 6.28. It's 57.3 degrees. So 1 radian takes up roughly, it's an estimate, roughly 57.3 degrees. And again, that always helps me because I'm always going to feel more comfortable looking at an angle in degrees, not radians. So when someone says, hey, I got an angle that's 3 radians big, I know that's about 3 times 57. Go ahead.
And the 6.28 and the 57.3, those apply for any circle, correct?
Any circle, right, because it's all objective to, you take a little circle and his radius is just that big, but there's still gonna be 6.28 of them that fit around a circle. Exactly.
It would be 360 degrees.
Exactly, okay? Good question. All right, so there we go. So that's a radian, so we gotta get used to that, all right? So for every radius that fits on that arc, there is an angle the size of 1 radian. All right, so here's our conversion factors. We just found out that 360 degrees all the way around is equal to 2 pi radians all the way around. Now guys, get used to it. We always put a little degree symbol when we label something in degrees. Radians usually don't get a unit of measurement. They usually don't get a label. They'll just say 2. So if the angle is too big, it's assumed to be in radians. They don't put radians a lot at the end. I tend to write it there just to kind of bring it home that it's in radians. All right. We can simplify this conversion factor though, divide both sides by 2, and now you know that 180 degrees is equal to pi radians. And that's probably the more popular conversion factor that we use because it's simplified. All right, so guys, if you want to go from here to here, 180 degrees, this is pi radians right there. 180 degrees is pi radians. Roughly 3.14 radiuses will get you to the other side of that x-axis. Okay, so to convert, if you want to go from degrees to radians, then you want to multiply by pi over 180, because that's the conversion factor, pi radians to 180 degrees. And I like to put my label there, because again, in chemistry, I was a big fan of that crossing out the units that cancel on top and bottom. All right, and then if you want to go from radians to degrees, they tell you to multiply by 180 degrees over pi radians. I don't do that. To me, it's much easier to go from radians to degrees because you know every time you see pi in radians, it's representing 180 degrees, and you can just pop that right in. All right, let's try converting. Let's see what we got. Have you been introduced to radians already? So this should all, did you? No? Okay. It depends on, again, last year I know was definitely different for everybody. And sometimes you end up seeing them in, I don't know if it's physics or science class. Some people are always aware of them.
Also, I just like this stuff better than algebra, so that's probably why I remember it.
Okay. All right, here we go. I'm not going to do all of them, guys, because I put way too many examples, like always. So I'll pick and choose a couple, and then we'll move on to the bottom examples. All right, so what if they asked you to convert 80 degrees to radians? Roughly, what's 80 degrees look like in radians? So you take your 80 degrees, right, and you're going to times it by the conversion factor. Just think pi and 180. That's our conversion factor. Well, guys, if I'm in degrees and I want to go to radians, then I want degrees to cancel on top and bottom. So you need your 180 on bottom and your pi on top. Just always remember you want your unit to cancel. So now my degrees cancel. My conversion in radians is 80 times pi over 180. And then to do that, you just reduce. So my zeros cancel. 8 over 18, 2 goes into both. It's 4 pi over 9. So again, a lot of times in radians, not always, a lot of times in radians, to give an exact angle measurement, you're leaving it as some fractional version of pi. So it's 4 pi over 9 would be its radian measurement, which if you do 4 times pi and divide it by 9, it's roughly 1.4. It's roughly 1.4 radians. So picture how far would one radius and 0.4 of another radius get you. That's the size of the angle in radians. All right, let's try 140 degrees. If I want to take 140 degrees and put it in radians, then we're going to times it with, I need my 180 on bottom, so my degrees will cancel. And I want to end up in radians, which is pi radians. But again, they don't label radians. It's just assumed to be radians. All right, so you get 140 pi over 180. Reduce it, and you get 7 pi over 9. 9 is not always your denominator. It just so happens the two that I picked end up with a denominator of 9. So it's 7 pi over 9 in radians, and then roughly, I didn't do this one. All right, and then pay attention on your homework. Sometimes they'll ask you to leave it as the reduced fraction, and then sometimes they'll tell you to round your answer answer to 2 decimals. Then you know you want to convert this. What is 7 times pi divided by 9? And get your radians that way. All right, we'll do this one, negative 30 degrees. All right, we're going to times it by 180 degrees. Pi on top, my degrees will cancel, so now I'm left in radians, and you get negative 30 pi over 180. Reduce it, and you get negative pi over 6. So negative 30 degrees is equal to negative pi over 6 radians. And guys, there's going to be some special angles that we deal with trigonometry, our 30, 60, 90, our 45, 45, 90. So 30, 60, 45, and any multiple of them are extremely special angles to us. So you're going to see a lot of pi's over 6 because that's a 30-degree angle and a lot of multiples of it. So pi over 6 is going to be one of our babies that we deal with all the time. All right, let me stop there. I'll do 107 though. That's a weird one. 107 degrees looks like this. Times, right, my degrees cancel. I'm left with 107 pi over 180. Guys, it doesn't reduce. So that's your exact answer. But because it's so weird and it's not a really nice reduced fraction, a lot of times with that one, they will ask you to convert it to an estimated decimal. So if you do 107 times pi and divide it by 180, it's about, what did I say, 1.9. 1.9 radians. It's almost 2 full radiuses that make up that arc. Okay? All right. Is everybody okay with converting that way? Everybody's good? So again, just pay attention whether they want you to leave it as an exact or they want you to round. Everybody at home, are we okay? All right, you're doing great, guys. Hang in. All right, now to go back. This to me is much easier to do because all I remember is that pi radians is equal to 180 degrees. Just remember that. I'll never forget it. I will be 90 years old telling my great-grandkids that pi radians is 180 degrees. So when you're in radians, every time I see a pi symbol, I just picture 180 degrees because that's what it represents in radians. So instead of doing my, pi over 3 radians, I'm going to times it by pi radians, right, if you think about that, and 180 degrees. And then our pi's cancel, and my radians cancel. 180 divided by 3 is 60 degrees. That's what they want you to do using the conversion factor, but I don't do it like that. I literally look at pi over 3 radians, and I literally say, pi is 180. What's 180 divided by 3? It's 60. It's 60 degrees. So when I'm in radians, I literally just pop a 180 in for pi. So if you look here, 7 pi over 4 radians. Yeah, you can use the conversion factor if you want. But guys, 7 pi over 4 is 7 times 180 divided by 4. I just pop a 180 in for pi. All right? And then another way to think about this that we're going to think about in the future, guys, pi over 4. What's 180 divided by 4? It's 45. This is 7 45-degree angles is technically what 7 pi over 4 is. And you'll get used to that kind of talk in the future. All right, but right now, 7 times 180 divided by 4, what is it, 315 degrees? And you're done. So to me, to go from radians to degrees is easier because I just pop a 180 in for pi. All right, look at this one. This one gets weird. See how it's just 2? You have to assume that's radians because if they don't label it with degrees, it's in radians. And a lot of times they don't label radians. I just like to put R or rads because it makes me feel better. But normally they don't label radians. So guys, this is 2 radians that we have to convert to degrees. So there's no pi for me to pop 180 into. All right. So then we're going to times it by the conversion factor. So we're going to times it by pi radians to 180 degrees. So my radians will cancel, and I'll be left with 2 times 180 is 360 degrees over pi. But remember, you're in degrees now. So pi is good old pi. So this is 360 divided by 3.14. But this is the most exact answer you can give me. But if you do divide it, did I divide it? It's about 114, 115 degrees. All right? And that's how we convert. Okay, now let's use it. Let's use what we know about how we measure things in radians. Most of your homework is converting, so it should be very, very quick.
After today, that'll be all that's on my homework that's due Wednesday night, right?
Today has its own homework, just on converting and a little bit of this. And then
So the one that's due Wednesday night
is just on degrees, minutes, and seconds, I think.
Oh.
And then, yeah, I like to do it by what I teach instead of giving you all the work at once. I like to kind of control it a little bit. And then today's homework will be due Thursday, and then tomorrow's homework on sectors will be due either Friday or, well, maybe the weekend. We'll see. I like to just take it in stages. All right, here we go. Look at here. This one says, find the length of an arc of a circle of radius 4 meters subtended by a central angle of 0.5 radians. So they're giving you this in radians. Well, guys, think about this. How do we measure an angle in radians? An angle in radians depends on the length of the arc and how many radius fit into that arc. That's how we measure an angle in radians. So picture this. We have a circle. All right. It has a radius of 4. Got it? And then it's got a central angle that is 0.5 radians. So guys, it's got an angle that's about 0.5 radians big. They want to know, find the length of the arc. They want to know this. What's the length of the arc that made an angle that is 0.5 radians big if the radius is 4? So now you just plug your radius and your angle in and you solve for the length of the arc S. So 0.5 radians is equal to what arc length divided by a radius of 4. So we're just solving this for S. So cross multiply. And S is equal to 0.5 times 4 is 2. The arc length is 2, and the arc length is always measured in the same unit as the radius. So the radius was in meters, so the arc length is 2 meters big. So to create an angle on a circle that has a radius of 4, that is the size of half a radian, the arc length must have been 2 meters long. All right? You guys try 7. Find the length of an arc of a circle of radius 2 inches, subtended by a central angle of 0.25 radians. So now what's the length of an arc created by an angle that is 0.25 radians big on a circle that has a radius of 2 inches? And you should find out that the length of that arc is about half an inch. Is everybody okay with that? Nice and easy. Just you have an arc length, you have a radius, and you have an angle in radians. Everybody at home, are you okay? Okay. All right, last one. You walk 5 miles around a lake. What did I write? Around a circular lake. Give an angle in radians which represents your final position relative to your starting point if the radius of the lake is 2 miles. So guys, you got a circular lake. Let's pretend that this is our starting position. The radius of the lake is 2 miles. You walked 5 miles around the lake. So let's just say 5 miles gets you to there. So the length of our arc, S, is 5 miles. They want to know what's the size of the angle in radians created by you walking 5 miles on a lake with a radius of 2. So remember, theta is always equal to the length of that arc and then how many radiuses fit into that arc. So theta will equal S over R. So 5 miles is the length of the arc. The radius is 2 miles, so theta is 5/2. It's 2.5 radians. So about 2.5 of a radius make up the length of that arc. And therefore, about 2.5 radians live inside of that arc right there. How do you guys feel, okay? All right, everybody at home, are you okay? Okay, so I'm gonna stop there. So today's homework, I hate even saying it to you guys, I think it's 25 questions, but guys, it's a few of these, real quick, just SR and theta, and then some conversion factors. And I say some, quite a few. All right, so I want you really trying to get used to degrees and radians and how to switch back and forth. But I get it, guys. Like I said, I've been teaching 17 years, and I still look at radians like, oh man, I wish we were in degrees, because it's just what we're comfortable with, okay? All right, tonight's homework I didn't make due until Thursday night, so I'm giving you guys plenty of time to try and find time to get it done, all right? All right, tomorrow we're gonna try to finish this section, but I don't know if we will, all right? If you have any questions, please feel free to stay, otherwise you are free to go, all right?